and the mother electronics in continuation of our video lectures, vsaqs for 12th class. Now, next one is Reoptics. Now, in this Reoptics vsaqs, the very first question is define focal length, and radius of curvature. For a concave lens. Now for concave lens means focal length of concave lens is defined as the distance between the optic center and focus. It is for concave lens the rays appears to be diverge or converge like. Here like the rays appears to diverge from that point. It is the distance between focus and optic center is called focal length. Focal length. The distance between the optic center and focus is called as focal length. Okay, concave lens. Now radius of curvature. Radius of curvature means what you know? Radius, it is the radius of sphere in which lens forms a part. Radius of a sphere from which lens forms a part or cut. It is the radius of the sphere from which lens is cut, or lens forms a part also you can write. Lens is cut also you can write. Anything same, convey same meaning. Okay. It is 2 mark question. I am not drawing diagram. Okay. Next, what is meant? What do you understand by? What do you understand by? By focus and principal focus in the context of lenses. Now, focus means what you know. Suppose, for example, when a parallel beam of light is allowed to incident on a convex lens, the rays will converge at one particular point. This is called focus. Okay, this is called as focus. Here is a point through which, when a parallel beam of light is allowed to incident on convex lens. The rays will converge at one point. It is called focus. Okay. Next, Now, principal focus. Principal focus means what you know? The rays coming from infinity converge at a particular point. The rays coming from infinity, the principal axis of the lens at which image of an object at infinity is formed. When object is kept at infinity, image is formed with a focus. That is called as principal focus. When the image is, when the object is at infinity, object is at infinity, image is formed at focus. This we call it as principal focus. This we call it as principal focus. With the help of convex lens, you can observe. When a parallel beam of light is allowed to incident, when a convex lens, the rays are getting converged at the focus, is called as principal focus. Okay, this is the second question. Now, third question is, what are the laws of reflection? What are the laws of reflection in the case of reflection through curved mirrors? So here, when a ray of light is incident on a reflecting surface, here this is incident ray, this is a reflected ray, and this is normal. AB, BC. So AB is incident ray. BC is reflected ray, OB is normal. So the first one is the angle of incidence is equal to the angle of reflection. First law, the angle of incidence is equal to angle of reflection. First one. Second one, the incident ray, AB incident ray, BC reflected normal should lie on the same plane. The incident ray the reflected ray and normal must lie on the same plane. With the diagram I explain. Even without diagram also they are writing, but if I draw diagram it will be more clear for you. Always, whether you measure angle of incidence or angle of reflection, always it is measured with the help of normal only. With respect to normal, sorry, not with the help of. With respect to normal only we are going to measure it. Followed? This is third question. The vsaqs are helpful in scoring marks. Though 4 marks and 8 marks, everybody can do it. 2 marks questions they get confusing. So we need to practice 2 times these questions. All basic level questions, and they will be useful for you to get the knowledge as well as marks. Define power of a convex lens and what you see. You need to define power of define power of convex lens and mention its unit. Now you know power of the lens is defined as the reciprocal of focal length also we will give, but exact definition is some textbook they given as the reciprocal of focal length is called as power, but that is not 100% correct definition, right? So we can write an example. Power is equal to 1 by f, we can write. It is a formula. The power of a convex lens. The power of a convex lens. This is mathematical form actually. Power of a convex lens can be defined as the tangent of the angle by which a lens converges beam of light converges beam of light falling on it, converges beam of light falling at unit distance, from the optic center. So, and my unit of power is diopters. Unit by capital D. The diopters capital D. See, focal length should be in meter. It should be in meters. Focal length must be. Focal length is in meters. Then only power is 1 by f. So take one. Power is equal to 1 by f. F should be in meters. Then only power will be in diopters. Unit of power is diopters. Okay. This is the fourth question. You need to practice these questions 2 times. Next question. Next objective question. A small angled prism. A small angled prism. A small angled prism of 4 degrees deviation. A small angled prism of 4 degrees deviation. Prism of 4 degrees deviation ray through 2.48 degrees. Find refractive index of the prism. Refractive index of the prism you need to find out. See, small angled prism means D is equal to mu minus 1 into A. This is answer. Answer is like this. What is the small angled prism of 4 degrees? Deviation is how much? How much you are getting? 2.48, no? It is 2.48 deviation. Mu minus 1 into A, 4. So mu minus 1 is equal to 2.48 by 4, that is 0.62 you get for this. Mu is equal to 1.62. This is the answer. Mu is equal to 1.62. Small angle prism, special formula. Below 5 degrees. If it is there, the prism is below 5 degrees is there, then we can call it as small angle prism. Simple question, 2 marks. This is the answer you got. Now a little more explanation I am giving rather than you find answers in any material slide. But I am giving more explanation and diagram based I am explaining so that you will be comfortable in writing exam and easy to remember also answers. Okay. Next we have a concave mirror. A concave mirror produces an image of a long vertical pin, long vertical pin placed 40 centimeters from the pin at the position of the object. At the position of the object. Find focal length of the mirror. Now in this case, u is equal to v is equal to minus 40 because both are the same side. Both are in same side, u and v. To the left of the lens, mirror negative, right positive. All negative. So you have formula 1 by f is equal to 1 by u plus 1 by v. Both negative, all negative will take. uv negative will take. Okay. Focal length also uv negative 1 by f is equal to minus 1 by 40 minus 1 by 40. 1 by f is equal to minus 2 by 40. F is equal to minus 20 watt. That is focal length is 20 centimeters. Answer is 20. Correct. This is another question about. Now regarding next question, second question, important. What is myopia and how it can be corrected? How it can be corrected? Myopia means, it is short-sightedness. You can see near objects or cannot see farther objects. Sightedness. So here, in this case, rays coming from this distant object is formed in front of the lens, in front of the retina. The image is formed in front of the retina. So actually, to have a clear vision, the image should form on the retina, but it is forming in front of the retina. So by using concave lens, we can rectify the defect. Okay. For that, I will draw diagram. Okay. Image is formed before the retina. Okay. Image is formed before the retina. Before the retina, image is formed. Image is formed before the retina. Okay, this is the retina. So this is defect. Now rectification how we do? Here, by using a concave lens you should keep in this. You have to keep concave lens in the path of this. Thereby, passing through this and exactly image is formed on the retina, like this. So rays are coming here, this is the object. Arrows important, okay? Arrows are very important. So image is formed before the retina, but by using this concave lens, by using type of defect in this distant eye of the object, distance defective eye, the image of a distant object, you can write here, the image of a distant object formed before retina is formed in front of the retina, formed in front of the retina. Okay, in front of the retina. It is called, the object can be by using a concave lens between the eye and the object. The defect can be corrected by keeping a concave lens between the eye and the object, between the eye and object. This is important question, 2 marks. Okay, what is myopia? You should draw a diagram first. You need to draw a diagram, both the diagrams you have to draw, and then you have to show it clearly before retina, on the retina is formed here. So by using here, this is concave lens. This is concave lens. Okay, important. Over the myopia. Short-sightedness also you can call it as. Follow by this diagram, everything. Okay. This is next we have got hypermetropia. What is hypermetropia and how it can be corrected? What is hypermetropia? How it can be corrected? Here, in this case, what happens, the image forms behind the retina. Now here, what I here like this. Image is formed behind the retina. Before the previous case, before, here behind the retina. This part is retina. Okay. Now to correct this is defective. How it can rectify? You can rectify by using convex lens. By using convex lens, you can rectify this defect. Now lens you can keep here. Let's put arrows. Okay. Arrows are important. Okay. Arrows you can keep here. So this is correction. So Image is formed when rays coming from a distant object. Image is formed behind the retina. Here in this case, rays coming from an object the image of a distant object formed behind retina. Okay, in this defect, image is formed behind the retina. It is also called as long-sightedness. Long-sightedness. Okay, this defect can be rectified by using convex lens between the eye and the object. Okay, this defect can be corrected by keeping convex lens between eye and the object. By keeping between eye and the object, you can correct this defect. By using convex lens. You can rectify this defect. Alright. These optics diagrams are important. If you draw a diagram, within no time you will get the answer. That's the advantage. Optics, you need to spend some time on diagrams. If you have diagram, within no time you can apply for formula or sign convention, you can apply and get the answer. The problem is many students will not have diagram. They want to work out orally, like by using formulas. Formula not very useful. First a diagram, then sign convention, then solve it. Then 3 steps if you follow, within no time you get the optics answers. Where is the image formed, where is the object formed, all that situations you have to be thorough. That is, for that you need sign convention. Suppose you take convex lens. Convex lens, you have to make use of first lens formula 1/p is equal to 1/v minus 1/v. So if you take like this, to the left of the lens negative you take, to the right of the lens positive. Okay, object kept here, image also here, both are negative. Focal length for convex lens always positive. Use this convention, you get answer. For concave lens, negative only. For this one, for concave lens, virtual image. Similarly, all optical instruments, virtual images. Okay, virtual images are erect, real images are inverted. Like this, wordings are there. Where is on that one, you can do it all, everything easily. Okay. Now the last question you have here. What is dispersion? What is dispersion? Which color is relatively more dispersed? So when a beam of light is allowed to incident on a prism, the light ray splits up into 7 colors. 7 constant colors. That we call it as dispersion. When light ray is allowed to incident on a prism, the ray will split up into 7 colors. That is called as dispersion. Okay, splitting off of light into constant colors. constant colors on passing through a prism. Is called dispersion. So violet color is more dispersed. Dispersion is more for right. The violet color is getting more dispersed. So these are the questions in Reoptics. Next we continue.